We'll start now with example 8 from section 1.3 on complex numbers. In example 8, we're asked to determine the character of the solutions of a quadratic equation. In other words, what do we expect the solutions to be? Do we expect to get two unequal real solutions? Do we expect to get one real solution that's a double root? Or do we expect to get two imaginary solutions that are conjugates, right? So that has to do with our what? How do we determine that? B squared minus 4ac, right? So a equals 1, and b equals -2, and c equals 1, and b squared minus 4ac will be -2 squared minus 4 times 1 times 1, or 4 minus 4, which is 0. And so when we have 0, that's when we have that double root. So it's a one real solution, right? It'll be real. That's the character of the solution. I don't know what it is. We weren't asked to find it. We're just asked to find the character of it. It's one real solution. You may also want to write a double root. Okay. Here a is 2, b is -3, c is 1, and b squared minus 4ac is -3 squared minus 4 times 2 times 1. So what do we get? 9 minus 8. 4 times 2 is 8. So we get 1. Okay, that's a positive number, so we would expect to get two unequal real solutions. Right? Okay, and then the last one, a is 1, b is 2, and c is 2. So b squared minus 4ac is 2 squared minus 4 times 1 times 2, or 4 minus 8, or -4. And what do we say? When it's negative, we expect to get two non-real solutions, two complex solutions that are non-real, but I'm fine with just two non-real solutions. And we can add that are conjugates, but that's not as important. We just want to understand that it's two real solutions, but I'll go ahead and put that are conjugates. But the main thing is that they're two non-reals. Two unequal real, two non-real, one real. That's a double root. Okay, so now let's use this information, use what we've learned to solve equations in the complex number system. We're going to use the quadratic, and we have to have it in standard form. So the first thing will be to add 5 to both sides. Identify a, b, and c. A is 1, b is 4, c is 5. We could do the b squared minus 4ac, but we know we're going to continue. It's not going to stop us if we get a negative. So let's just go on to the quadratic. X equals -b plus or minus the square root of b squared minus 4 times 1 times 5 all over 2 times 1. -4 plus or minus the square root of what? 16 minus 20 over 2. -4 plus or minus the square root of -4 over 2. And that's -4 plus or minus, what's the square root of -4? 2i. Yes, the radical goes away. We take the square root of 4, we get 2. We take the square root of -1, we get I. The radical's gone. Okay, we need this to be an a plus bi form. So we have -4 over 2 plus or minus 2i over 2. Simplifying, that's -2 plus or minus I. So in other words, we have -2 plus I, comma, -2 minus I. Notice, now we can really see that conjugates of each other thing, right? -2 plus I, -2 minus I. We got two. Our b squared minus 4ac was negative, and we got two non-real solutions that are conjugates. Okay. Again, we've got to get this one in standard form. Subtract 3x. Identify a, b, and c. And let's get our quadratic going. negative, and be careful, b is negative, so that's going to end up being a positive, plus or minus the square root of b squared. B squared will always be positive because a negative squared is a positive. Be careful, don't let your calculator, if you type in negative 3 squared, it might give you negative 9 if you don't use parentheses, and you know that's not right. 4 times 1 times 10, all over 2 times 1. So we have positive 3 plus or minus the square root of 9 minus 40, all over 2. Okay, so that's 3 plus or minus the square root of negative 31 over 2. All right, so that's 3 plus or minus this I times the square root of 31. I don't need to keep showing you that I'm factoring a negative 1, then taking the square root of negative 1 and getting I, right? We've got that now. But the 31 has no perfect square factors, so it stays. But this is not an a plus bi form. To get a, I put 3 over 2 plus or minus I. Let's see, I'm going to put my I at the end, so square root of 31 over 2 I. Make it clear the I is not under the radical, but there's my A, there's my B, and there's I. So I have these two solutions, 3/2 plus the square root of 31 over 2I, comma, 3/2 minus the square root of 31 over 2I. Conjugates. Okay, C is not a quadratic equation. It is a 4th degree equation. So let's see what we could do with that. It's possible that it might be factorable. Let's see. Let me try to force this into a factoring situation. X to the 4th, and that's an x squared. So maybe if I put an x squared here and an x squared here, first times first will give me that, and then I've just got to generate 3x squared and a minus 4. So two numbers that multiply to negative 4 but add to 3, what, plus 4 and minus 1? Okay. So x squared plus 4 equals 0, and x squared minus 1 equals 0. We're looking, because it's a 4th degree, there should be 4 solutions. Let's see. X squared equals negative 4. Aha! This is where our imaginaries will come in. The square root of x squared equals plus or minus the square root of negative 4. So x equals plus or minus, what's the square root of negative 4 again? 2i. Radical's gone. Here, x squared equals 1. Take the square root of x squared equals plus or minus the square root of 1. That's a perfect square. It's a real number. Plus or minus 1. So we did find 4 solutions. We found 2i, negative 2i. Those are conjugates. They're just pure imaginaries. 1 and negative 1. Okay, another 4th degree equation, but this one only has the x to the 4th, no other powers on x. So let's write this as x to the 4th minus, let's try this. That looks kind of funny, but if this is that's a perfect square, right? That's x squared squared. What if 1296 is a perfect square? Take the square root of 1296. 36. Okay? So we have an a squared minus b squared. How does that factor? Difference of squares, right? So it would be x squared minus 36, x squared plus 36. Now just check me on this. FOIL. First times first is going to give us that. The middles are going to cancel. Negative times positive negative. 36 times 36 is 1296. So we have x squared minus 36 equals 0. X squared equals 36. And take the square root of x squared plus or minus the square root of 36, and we get x equals plus or minus 6. Two real answers. X squared plus 36, however, is going to give us x squared equals negative 36. Square root of x squared equals plus or minus the square root of negative 36. What's the square root of negative 36? 6i, right? So our 4 solutions are 6, negative 6, 6i, and negative 6i. And that completes section 1.3.